So let us look at Clausius inequality in order to understand entropy. First, let us see what is Clausius inequality. Clausius inequality, again, you can see that there is a high temperature reservoir at TH and a low temperature reservoir at TL. So this is a heat engine which receives QH and rejects QL and produces work QH minus QL. And you can take an irreversible heat engine which takes in heat QH and rejects QL dash and produces a work QH minus QL dash. So efficiency of a reversible engine is equal to 1 minus QL by QH is equal to 1 minus TL by TH. And efficiency of an irreversible engine is equal to 1 minus QL dash by QH, which is less than 1 minus TL by TH, because efficiency of an irreversible engine will always be less than efficiency of a reversible engine according to the Carnot's principle. So that means QH by TH minus QL by TL is equal to 0. This is for a reversible heat engine. And that means, just like we have seen earlier, the integral delta Q by T will be equal to 0. And for an irreversible heat engine, you can write QH by TH minus QL dash by TL is less than 0. So cyclic integral of delta Q by T is less than 0 for a irreversible heat engine. Okay, so this is for a reversible heat engine. So delta Q by T cyclic integral less than 0 for a irreversible heat engine. So that means you can write the cyclic integral of delta Q by T will be less than or equal to 0. So this is Clausius inequality. That means for a reversible engine, cyclic integral of delta Q by T will be 0. And for an irreversible engine, delta Q by T will be less than 0. And if cyclic integral of delta Q by T is greater than 0, you can definitely say that this is an impossible engine. This is an impossible, because according to Clausius inequality, for any cycle, delta Q, cyclic integral of delta Q by T will be less than or equal to 0. This is what Clausius inequality says. So we have seen that for a cyclic process, you can see that the property of any property, if you take for a cycle, it will come back to 0. For example, if you take the temperature here at state 1, if it comes back to these initial states, its temperature will remain same. Okay, if you take pressure for a cycle, it starts from a point and again comes back to that point, so the pressure will remain same. So this is for the pressure and temperature. So for any property, if you take a system, if it undergoes a cycle, its property after one cycle will be same. So that means cyclic integral of delta T will be 0 for a cycle, and cyclic integral of delta P will be 0 for a cycle. So if you look at this equation, the cyclic integral of delta Q by T is equal to 0. From this you can infer that this is a kind of property, delta Q by T, that is a property of the process, and this property is called the entropy.